Good evening, participants. Let me introduce our speaker for the day, Dr. Lakshmi Narayanan. Sir is currently working as a professor in Francis Xavier Engineering College, Tirunelveli, India. Sir has got his PhD in VLSI-based image processing from St. Peter's University, Chennai. Sir has received his master's MTech from in VLSI and embedded system from Dr. MGR Educational and Research Institute University, Chennai, and his BE in Electronics and Communication from Dr. Shivanti Aditnar College of Engineering, Tiruchendur. Sir is having about more than 13 years of academic and 2 years of industrial experience. And sir is also a mentor trainer for IoT for non-mutual scheme of government of Tamil Nadu. Sir is also a DGCA licensed drone pilot. Apart from this, sir has organized various workshop, AICTE sponsored STTPs for faculties and students, published number of high impact publications in journals in the area of artificial intelligence, deep learning, communication, IoT, image processing. Sir is also a reviewer of multiple journals, IEEE Access, Springer, many other indexed journals. Sir is having Sir has been a receiver of many design project, design patents, many innovative products, grants, etc. And a member of IEEE, CSTA, ISRD, and many more. Sir is head of FXEC Business Incubator, and about 6 projects are running under his guidance. So sir has wide experience in both academics, industry, and especially with the topic that is IoT. So hope we will get lots of knowledge from sir. So we are lucky to have him for this particular session, 1.5 hour. So participants, be attentive and try to gain as much as possible from sir. Thank you very much, sir, for accepting our invitation. You may start now, sir.
Thank you very much, sir. It was great hearing from you.
Yes, sir.
Let me share my screen first.
Yes, sir. Yes, sir. The slide is visible.
The slide is visible now.
Yes, yes.
So very good evening to all our present
Yes.
here. It gives me immense pleasure to talk to you regarding Internet of Things in smart city applications. So I thank Dr. Ravish Hirpra, Associate Professor, Electrical Engineering Department, Coordinator of ATAL FDP, and the organizing team of SN Patel Institute of Technology. So this will be our outline of today's session. So initially we'll get into the industrial revolutions. So what exactly happened in the industrial revolution, and later on we'll see about the basic introduction about what is exactly an IoT, and into our topic, that is IoT in smart city applications. So as far as industrial revolution is concerned, it started in the year 1784 in London actually. So initially, the dress materials which was fabricated for human beings was done in their homes itself in late 1600. So later on, in the year 17 or late 1700s, the requirement for the this dress materials is becoming higher and higher day by day. So they started inventing looms, weaving looms. So if they are manufacturing more and more dress materials, they need some transportation through which they have to transport all these dress materials to one point to the other point. So at that time they invented steam engine. So the industrial revolution 1.0 began there. Secondly, the industrial revolution 2.0 says about the mass production. So anything which is manufactured, it was produced in a mass way, like in an assembly line, or using the electrical energy. They started manufacturing everything. That is considered as a industrial revolution 2.0. And industrial revolution 3.0 tells about how an automation is involved in all these production kind of things, and how electronics and computers were involved in doing all this production on manufacturing of things which was happened. That is using integrated circuits, how this manufacturing process got started. So all these are done in the industrial revolution 3.0. And currently we are traveling from industry 4.0 to 5.0. So 4.0 is nothing but cyber physical systems, Internet of Things. So how a machine is communicating with another machine, so that the input from one machine is going into the other machine. So how it is responding corresponding to the input, and what exactly the output which you are generating from the received input. So that we call it as an industrial revolution 4.0. The communication plays a very important role in industrial revolution 4.0 exactly. And towards 5.0, that is after 2020, we are traveling towards 5.0. So we are just trying to collaborate all Internet of Things, artificial intelligence, and with the help of the human intervention, we are developing maybe more and more application with these three collaborations. So this is about the industrial revolution. So the basic glimpse about the future of Internet of Things, because uh, Internet of Things is a major thing, major breakdown in industrial revolution. So Internet of Things as a glimpse, if we see, as per mechanical research done in 2020. So they're predicting that this five predictions for IoT. That is, the globally in the year 2025, we are expecting around 27 billion global IoT connections in the year 2025, and the revenue which will be generated will be like around 3 trillion US dollars, and the cellular based IoT connections will be around 2.2 billion, and the cellular based IoT connections for the connected cars, that will be around 45 percentage, and there will be around 2 zettabytes of data which will be collected through this IoT for the consumer, from the consumer devices to the analytical purposes. So these are the glimpse of the future of Internet of Things in the year 2025. The impact of IoT, as we talk about the impact of IoT, like in the year 2010, we can able to like we can even find, like we can figure it out. Each person will be having around at least one device. In 2015, like we got like our mobile phones, which is a connected device, like which we may have around 2 or 3 devices. So likewise, it was predicted like around 2025, each and every one of us will be having around 9 to 10 number of connected devices, which will be powered by Internet of Things. So this is the statistics done in the year 2020. So as far as we talk about the smart systems and IoT, the smart systems and IoT are driven by the combination of sensor and an actuator, connectivity, people, and process. Here we can see a small example of what is exactly a sensor and an actuator. A sensor is nothing but like we can just imagine that it is a boiler. So it continuously detects the temperature of that boiler and it sends the signal like every uh, frequent time it will send a signal to a control center. So the control center receives those signal and it works accordingly. That is, it commands the actuator whether if the temperature is beyond the threshold limit, then it starts sprinkling the water. So this is actually the relation between a sensor and an actuator. So this is actually a smart system. So smart system is nothing but without any human intervention, if it is taking any action. So here we can able to see there is a boiler. If the temperature is going beyond the threshold limit, so it automatically sends the command to the actuator. The actuator is nothing but a small sprinkler. So the sprinkler turns on if the temperature goes beyond the threshold limit. So as far as Internet of Things is concerned, it is described or it is defined as it is a network of physical objects or things that are embedded with sensors, software, and other technology for the purpose of connecting and exchanging data with other devices, systems over the internet. So it is nothing but it is a combination of some sensors, softwares, and with the help of some technology. So it is exchanging the data from one device to the other device. That we call it as a Internet of Things. So this is the very common definition which is given in the Wikipedia. So as far as Internet of Things, as we told, as per the definition, it is a combination of sensors, connectivity, people, and process. So sensors, we know, like we have a lot of sensors available in the market in recent days. So here are a few sensors which we are commonly used in normal college level projects, like starting from ultrasound, RFID, magnetic sensor, electric sensor, leak level sensor, force, load, pressure. So if we want to measure any weight of a particular object, we can go for this force, load, and pressure sensor. Motion sensor, velocity sensor, and humidity and moisture sensor. So all those things, like we can able to measure the atmospheric parameters, temperature parameters. So ambient light, flow, acoustic sensor, chemical and gas sensor, position, that is nothing but your GPS sensor, vibration sensor, acceleration, like gyroscope. So all these sensors are available in the market in recent days for doing a small project, small projects using our Arduino, basic Arduino. And these are few sensors which we commonly use. That is LM35, which is a temperature sensor. Accelerometer is nothing but the gyroscope, which we commonly use. Like if a particular device is connected with this accelerometer, if that device is moved from one position to the other position, this accelerometer can able to sense that and it can able to give some alarm or make some actuations. So this DHT11 is nothing but it's a digital temperature sensor. It can able to collect the ambient temperature and the humidity. So the other things are the actuators, solenoid valves, switches, then DC motors and motors. All those things are actuators. The sensor sends those atmospheric informations, and these actuators are used to take some actions corresponding to the input which is given to the controller. So while talking about the connectivity, like initially there was uh, like a mobile phone. If we consider our mobile phone, like two the devices communicated using we have like, if we talk about that feature phones like black and white phones. So if we need to communicate our data between two different phones, so we try to communicate using this IR, infrared. So then later we got our Bluetooth, and now we are in wireless mode, that is IEEE 802.11, that is Wi-Fi based. We can able to transfer the data. So similarly, in the Internet of Things also, initially there was Bluetooth, then there comes the Zigbee, then GPRS came into the action, like using SIM card, some data will be transferred from one device to the other device using your GSM signal. And now currently we are using LoRa, that is long range RF communication. Likewise, uh, based on the complexity of the device and based on the requirements, different connectivity devices was actually invented in the long run. So these are few connectivity devices for IoT. Like we can able to use Bluetooth. This is the first model. Bluetooth module can be used. So if the connectivity is between like around 10 meters range, then we can able to use this Bluetooth. Like if the connectivity is little longer, then we can go for Zigbee, like around 30 meters. If it is like if a long distance travel, a long distance communication, that we can use Wi-Fi, that is ESP8266 or ESP32, which we can able to use. Or otherwise, like if we don't want to use any internet, if there is a requirement like we need to transfer data without any internet, we can go for this LoRaWAN. Without any internet, it can able to transfer data till 4 kilometers if both transmitter and receiver are there in the line of sight. So again, we have narrowband IoT, that is also will be using your internet service. And along with this sensors and connectivity, and where exactly we are going to use, whether this particular thing is going to be used for performing some analytics, or it is going to perform some remote monitoring, or it is going to perform some control or automated related things, or it is going to be applied in supply chain thing. So for which purpose it is going to be used. So all together we call it as an Internet of Things. That is a sensor, connectivity, people and process. Where exactly we are going to apply this? So entirely we call it as an Internet of Things. So the interaction between these entities, that is sensors, actuators, connectivity, people and process, are creating new types of smart applications day by day. So here we can able to see few smart application. The first one is thermostat. Normally it will be fixed in like in India, most probably we will not be having these things. So it is being used in developed countries or cold countries, like it is called as Nest. Nest is nothing but it continuously monitors the temperature inside the house. So if it is required, like it needs to increase the temperature of the room or inside the house, this helps in raise the temperature or pull down the temperature. For that purpose, this thermostat, smart thermostats is being used. And the secondly is connected cars, through which we can able to track the rented cars. That is, if we like if we are having a car, we can able to connect it with Ola or Uber. So using this connected car, these things, what we can do is we can able to track where exactly our car is moving, and what kilometer it is running every day, so that we can able to monitor from the remote itself. So that we call it as a connected cars. So activity tracker is nothing but normally we in recent days we are using a lot of smart watches. So so that we can able to track how much sleep we are taking every day and how much walking we are going every day. Like what is our blood pressure at that point, and what is our oxygen level in our body. So everything can be tracked immediately, and it can be viewed by a person who is located remotely, and take some actions if it is required, if it is any sudden requirement is needed. So next is smart outlets. Smart outlets is nothing but we call it as um, smart plugs. Smart plugs is nothing but if you have a laptop, so we used to put charge and forget to switch off the charging. So if it is like a smart plug, we can able to set the timer so that after a particular duration of
Excuse me,
one.
sir.
Yes, sir.
Please hide your tab, sharing tab. There is a hide means no.
Pardon, sir.
Someone means participants told write the message request. Please hide the down strip teams share by your screen. Means
One
whenever
minute.
you share the screen, hide your sharing tab so that they can read all stripes.
Okay. Sure,
Okay,
sure, sure.
okay. Otherwise, it's okay, sir.
Okay. This one, right?
Yes. That tab hide. Okay, sir. Good, fine.
So this is about the smart outlets. Smart outlets is nothing but smart plugs. As I told, like if we forgot to turn off the laptop charger, so this will help us. Like we can able to set the timers so that automatically, if the time comes, it automatically turns off, so that we can keep our laptops and mobile phones safe. And at the same time, from the mobile itself, we can able to control these kind of smart outlets. So that is smart plugs. So this is also one of the smart application in recent days. We can able to have these things in our normal Amazon and Flipkart itself. It has been available right now. And next one is smart parking sensors. The smart parking sensors is nothing but like in India, slowly it is coming. Like wherever the parking is available in a city, if it is a busy city, we need to find some place to park our car. So if you are going to a shopping mall, there will be a parking. If we go for a marriage hall, so possibly we cannot find much of parking over there. So if it is a busy city, we need to find a parking so that we can able to keep our car very safely. So this parking features help us to find where exactly we can able to park our car. So through the mobile application itself, what we can able to do is like in that particular city, where exactly that nearest parking is available, so that we can able to park our car safely. So all these things are coming under this smart applications. So apart from that, your Internet of Things is having a wide variety of application. Like it starts from home user. Like we all know that like home automation is a very excellent example for Internet of Things. Like whenever if we need to come to home, so like if the AC needs to be turned on, we can turn it on from our office itself. So that's an excellent example. So transport and mobility, health and body, building infrastructures, smart cities are some recent good developments in Internet of Things, which is not limited to this. So as far as our topic is concerned, that is IoT in smart cities. So this is the outline which we are going to deal it today. So where exactly what are the things we are going to incorporate in the smart city applications. So the first one is smart manufacturing, then a smart mobility and Wi-Fi, and then how a smart parking system is going to be involved, and how a smart transportation system is going to be involved, and what is a smart building, and what is a smart farming, and what is a smart health, which is taking place in the smart city application. So all those things we are just going to see it in the smart city components. So smart manufacturing is nothing but a smart factory is a concept of delivering a Internet of Things that is like without the human intervention, the manufacturing process entirely will be carried out. It is a fully automated or intelligent network of system that enables the facility, machines, and logistic chains within the manufacturing plant to be managed without any human intervention. So from the starting to the ending, without or with the partial involvement of the human, if it is happening, then we call it as a smart manufacturing. So right now in India, we are starting these kind of operations for small industries like PCB manufacturing, so mobile phone manufacturing, then small car manufacturing. So all these industries are now incorporating these kind of smart manufacturing systems. Either completely it will be an automated one, or with a very few human interventions, these things will be happening right now. So here we can able to see few smart factory applications or smart manufacturing applications. So in case of this PCB, the in the turbine, each and every robotic component will be having some certain application. One to fix a component in the PCB, other to solder that PCB. Likewise, a simple application to very complex applications such as making a welding, arc welding or dick welding, like anything we can able to do it using this smart factory applications. So all these are coming under Industry 4.0. So this is about the smart factories. So in case of smart transportation, like efficient traffic management, automated toll ticket, then self-driven cars, automatic vehicle tracking and transportation monitoring, and enhanced security for public transport. All these things comes under the IoT in smart transportation, which also comes under IoT smart city application. So efficient traffic management is nothing but we know very common traffic management system is all our traffic light signals are right now controlled in a wireless way, so that if it is happening like a very huge traffic is happening, so your person can control from the control station, so that the traffic can be regulated smoothly. Or otherwise, we can able to take this example, we are if we are trying to move from one place to the other place, we used to take with the help of the Google Maps. So Google Maps in recent days, it can able to tell where exactly the traffic is heavy, so that we can able to avoid those uh, uh, routes, and we can able to take other routes. So in case of FASTag or toll collections, also we are using this smart transportation, because in previous years we can able to see that the vehicles need to wait for a long time to give money, and then they will be giving a challan, and then the toll gate opens, then the car moves. Now it has been everything and automated, that using Internet of Things. The camera scans the FASTag, and it recognizes the things, whether the amount is available inside the FASTag or not. So sensing it all in a very fraction of second, it automatically opens the toll and the car passes it very smoothly. And the next is the automated cars. Now, as far as Industrial Revolution 5.0 tells about, so how we are going to use machineries without any intervention of human. So here, this is one of the example, so that using cameras and sensors, so how we can able to drive a car without hitting on the obstacles, or without creating some traffic nuisances. So this is also one of the application of smart transportation. And next is we can able to track where exactly the car is rightly present. So if there are some devices recently available, we can able to track our car, which is being very much necessity in metropolitan cities. So if we are connecting our cars with Ola and Uber, or otherwise if our friend is taking our car somewhere, we need to keep on waiting for a long time. Or what we can do is we can just take our mobile phone and we can able to track the car where exactly the car is located, so that we can have a safe communication with our car. So these are few examples of smart transportation system under smart city applications of Internet of Things. So this particular car tracking will be consisting of normal controller, so which is powered by a GSM modem, so that internet will be supplied from that GSM modem, and there will be a GPS system available so that to track the latitude and longitude of the car where exactly it is located. So it will be connected with the mobile application so that the data comes serially inside your mobile phone, so that we can able to locate the car where exactly it is standing. So these are few applications of smart transportation. So apart from that smart transportation, we are now able to find automatic car parking. So if it is like automated cars, there is no human driving this car. In the previous slide, we can able to see this is an automated car of Tesla. Without any human intervention, it can able to drive the car. So likewise, it can able to park the car in the parking where exactly it is available. That is the collaboration of the previous one. That is, we talked about the automated car parking, isn't it? So that using that automated car parking, it can able to identify where exactly the car parking is available in the city, so that this car can go to that particular parking lot and it can park itself and it can satisfy its applications. And the other thing is like in recent days we can able to see this speed monitoring device kept in the highways. So it can able to recognize the speed of the car, and it automatically senses the number plate. If it is crossing its threshold speed level, automatically the fine will be generated on that particular number plate and it will be sent to the consumer's home. So these things comes under the smart transportation system. And so this is a case study, like it is a smart transportation from with smart city applications. Like there is a person like she's taking her son to the hospital. She's driving a self-driven car. So these things are right now available in market using this Tesla cars and all. So what we are doing is like we are incorporating all our credit card details with the car, so that what exactly it is doing is the self-driven car is dropping them in the hospital, and it automatically finds a parking spot and it automatically parks there. As the credit card is being incorporated with the car, it automatically pays the parking fees. And at the same time, if there is any mechanic required for looking at the fault inside that car, it automatically it can able to book a mechanic, so that the mechanic can come to that parking and it can able to rectify the fault. And for that mechanic also, we can able to make a payment through the automatic payment which is available in the Tesla. So these are being incorporated in recent days. So this was the system actually for smart parking system. So here we can able to see that each and every parking lot is having a small parking sensor, geomagnetic detection system. So what exactly it is doing is whenever the car comes and stand above the geomagnetic detection system, it detects that car and it sends the signal to the centralized base station. So for every region there will be a base station. So that base station will be collecting all the details about the available parking lots. So based on this, this communication base station will be sending the data to the cloud, so that from the cloud we can able to monitor all the details about the parking availability in the mobile phone. So when we are entering into this particular place in the smart city, so we can able to find, okay, these are the places which are available with the free slots, so that we can able to park it safely. So this is about the smart parking system in the smart transportation. The other major important thing in the smart city application is IoT based corporation waste management system. So in recent days, like each and every streets are having this garbage cans. So this garbage cans is actually like it is kept without any sort of electronics in it. But in near future, there is a plans these cans will be incorporated with all sorts of controllers and sensors and actuators. So these garbage cans, whenever it is getting filled, it automatically gives a signal to the base station, and from the base station, it connects to the cloud, so that from the cloud, the corporation people can able to monitor that particular garbage can is getting filled. So if in case some animals hit that garbage can, so if the garbage can fall down also, it can able to sense using some sensor, that is fall sensors are available, or we can even make use of accelerometer, so that we can able to find whether the garbage can is standing or it got fall down because of this animal intervention, so that the people from the corporation can able to sense those things, and they can send a garbage truck to that particular location, and they can proceed with the cleaning process. So this is about IoT based corporation waste management system. So this can be implemented not only uh, this one, like it can able to this garbage can, what it can do is like it can able to kept in each and every end of the city, so that each and every garbage cans will be connected as a wireless network, so that data can be used what we can say if it is connected in a network, means we can able to reach the cloud very shortly. So with the minimum number of gateway, what we can do is we can able to reach the cloud. Next is precision agriculture, that is smart farming. So smart farming is also a part of the smart city applications in recent days. So in smart farming, we have some various categories. Like in smart farming, in agriculture, what we'll be doing is like we'll be continuously monitoring the parameters, environmental parameters like temperature, moisture, what is the humidity available. Based on that, what we will be doing is we'll be pumping the water to the agricultural field. So this is about the smart agriculture, and in recent days we are incorporating drones. So drones is also a part of a um, uh, smart city application or smart agriculture. So that this particular drones now in recent days they are used for spraying medicines, fertilizers, or otherwise it can able to sow the seeds for in mountain areas, so that proper cultivation can be happened, or proper cultivation can be controlled in this mountain areas. And we have some drip irrigation systems which can be able to control using internet of things. So based on this water humidity and the uh, uh, humidity, temperature, and moisture level, this drip irrigation will be controlled. So whenever it is required, we can able to turn on this drip irrigation, and we can able to turn off the things. The other important thing is livestock monitoring system. So livestock monitoring system is nothing but if we are in need of tracking certain things. So if a cattle is a part of agriculture, okay. So if we are having a bunch of around a dozen of goats and a dozen of cows. So if a small tag is being connected to this to the neck, so we can able to track where exactly that cattle is being standing. So we can able to keep track them. So this is also a important application of smart city applications. That is livestock monitoring system. This is not only for them. So if our kid is going to the school, there will be a small GPS systems available. So we can just have it in their bags, kids bag, so that we can able to track where exactly the college bus or school bus is going. So we can easily track like whether they are going in a proper road. So there will be a option called geofencing. So if the normal route is bypassed and if they are traveling in some other route, it definitely gives a signal to us so that we can able to take actions in the right time. So this is what we call it as a livestock monitoring. So this livestock monitoring is having like around multiple applications. So livestock monitoring, the first is milk monitoring system using IoT. So as this IoT and embedded system is concerned, in recent days, automated milking system is been implemented in recent days. So this milking system collects the milk. It analyzes the quality of that milk, and at the same time, it will be connected to the centralized database based on the quality of the milk. The rate will be fixed, and the all the production related things will be controlled using the internet of things. And the secondly, the cattle's health can also be monitored. like these are few diseases which frequently affects the cattle, that is foot and mouth diseases, mastitis, lump skin diseases. So all these diseases are very frequently attacked to this cattle. So what we can do is we can attach a band in the cow's neck, so that what we can able to do is we can able to continuously monitor the cow's parameter vitals, so that like temperature, its activeness, how it is walking. So all those things can be monitored. Based on that, we can able to put it into a collection, and we can make an analysis whether the cow is healthy or it has been affected with some kind of disease. So this is the second application in this livestock monitoring. And the next one is the same thing which we have seen earlier. So there is a process called the geofencing. So if the cattle is going beyond that particular area, marked area, so this is this the tag which is being connected in the neck will automatically detect that geofencing area, so that the latitude and longitude will be marked. If it is going away from that latitude and longitude, so that tag will be sensing those things. That is that there will be a GPS over there. So it senses those location, and it automatically gives a communication to the owner, so that owner will be taking a action regarding where exactly the cow is actually standing. Then the next one is rumination monitoring. Rumination monitoring is nothing but cow will go and eat the grass, and after some time, it brings out that the food which it have taken, and it ruminates again, that is it chews again. So this actually gives the digestion for that cow very good, will be very good. So the rumination is a process. If the cow is ruminating again and again, then it is like it is considered that the cow is in good health. So this can also be monitored, how this cow is ruminating, and how this cow is whether it is active or not. So it will be connected to a small gateway. So from the gateway it will be connected to the cloud. So from the cloud we will be doing certain analysis, so that from the analysis we can able to analyze whether the cow is actually in a good health, or it has been attacked with some any kind of disease which is related to the rumination. The next application is the smart buildings. The smart buildings, we know that in recent days, most of our houses are constructed with um, automations or home automations. So if there is a requirement, like we can able to turn on or turn off automatically, and at the same time from the mobile itself we can able to control everything. So there will be a solar panel, solar based system, so to continuously monitor what is the voltage level exactly available in the battery. So all those things can be monitored from the remote place itself. So this is about the smart building. So this is also one of the key features of smart city application, as this uh, smart home automation is not which is very common to all. We'll go on to the next one. And IoT is not for a simple application; it is also for life critical applications. So uh, we know that we have some smart bands available in market, so that it can able to sense what is the body temperature, what is the pressure levels, and what is the oxygen level which is available. But right now we have like around like glucose sensors are available. In recent days we are having some advertisements coming, like it can able to sense what is the glucose level in our body, and it will be communicating with the caretaker. So if the caretaker gives an acceptance, there will be a small insulin pump connected in the connected to that belt. We can able to see that human belt. So this insulin pump will be injecting a small amount of insulin inside the body based upon the requirement or based upon the input given by the caretaker. So like this, a life critical applications is also available in the IoT in healthcare applications. So this is another case study. So here, like in US and Europe, most of the people are there is averagely 65. So most of the houses will be incorporated with sensors, and they will be continuously monitoring the parameters of the or vitals of the aged people who are living alone in that home. So if a person is falling sick, that sensors and actuators which are connected inside that home will automatically call for a ambulance system, so that the ambulance will be coming to that particular place if that person is falling in a sick, so that we can able to take some immediate actions if this kind of a situation happens. So this comes under the healthcare and smart home applications. And in IoT in retail industry, so this is also a very important thing, and in recent days. So like IoT, you can ask like how it has been used in retail industry. So like if we go into a supermarket, there will be a lot of trays over there. There you can just imagine that there is a 5 liters of oil in a particular tray. So there will be some sensors incorporated in that tray that will be continuously monitoring whether there is a 5 liters of oil in that particular tray. So if 1 liter of an oil is being removed, that sensor, that is the load sensor, will be continuously monitoring the weight of that particular tray. If 1 liter is being removed, but the balance will be 4 liters. So that will be detected with the help of the sensor, so that that sends an intimation to the distributor, so that the distributor comes into the supermarket and refills the oil can. So this is how your retail industry is being using your Internet of Things. And at the same time, like there are more analytics things are available. Like in recent days, we can able to find like gold shops are using some virtual technologies. So all the jewelries will be available in the virtual banner. So the shops will not be a bigger size shops, it will be a smaller size shops. So it will be a virtual one. If we go and stand before that virtual machine, so we can able to see like how that particular gold ornament suits for us. And at the same time, this is happening for the dresses also. So we don't want to wear it and see, like if we go before that machine and if we stand before that machine or that mirror, what we can able to do is like it automatically puts that in a virtual way, and we can able to see whether that particular dress material is suiting for us, or how it is getting fitted for us. So in this way, what we can do is like we can incorporate a lot of Internet of Things kind of applications in retail things, retail industry. Not only in retail industry, like IoT, along with data analytics, what we can do is, so in recent days, it has been applied in the sports industry also. So we can able to see this person. This is Anil Kumble. He introduced the spectrocom technology in cricket in 2015. So what exactly is like this bat will be having some kind of a sensors, so that if a batsman is playing with that particular bat, he can able to analyze like how he is reacting to that ball, and how the spin that is swing of his bat has been happening corresponding to the ball. So whether the ball is hitting the bat or not before the catch by the wicket keeper, so all those things can be monitored using this IoT enabled bat or sensor enabled bat. Not only for this cricket, it has been applied for tennis also, tennis racket also. So we can able to analyze how quickly we are spinning our racket. So how how speedily we are attending that ball. So all those analysis we can able to sit and view it after the game. So this is about the IoT in data analytics, or that IoT and data analytics in sports. So here are some top 10 areas where IoT is being applied like in recent days. So this is it. Like in the top first position, it is in the manufacturing industry, and secondly, it is in transportation, and thirdly, energy. Fourth is retail industry, and fifth is smart city applications. Sixth is healthcare. Seventh is supply chain. Eighth is agriculture. Ninth is smart buildings. And tenth is the other things which are not in the list. So these are some top 10 applications where your Internet of Things is being applied. The fact is like this can actually happen in near future. Like machines can communicate with the human mobile phones, so it can able to tell whether to our refrigerator might talk to us like to buy milk. So if we didn't buy milk, it can able to scold us. So this is possible in the near future. So your smartphone and smart house may lock itself, and they might not allow you inside the house. So this may also happen in the near future. So now let us see some hands-on sessions. So so as far as we saw about some theoretical part, so now I'll show you some hands-on part. So so as far as Internet of Things is concerned, it largely depends upon embedded system. So this is an excellent platform where we can able to practice embedded system without getting any hardware things in the from the market. We can able to start exploring how we can able to use embedded systems by using some simulation tools which is available in the online, right? So the first thing what we are going to do is we are just going to enter into this particular um, website, that is www.tinkercad.com. So you can have a glance in that. So after this session, you can able to try it of your own. So this will be a demonstration session. You need not to do it along with me. You can just have a look at it. So this is www.tinkercad.com. Like we need to log in. So if we log in, it will ask for login. So here what we have to give is you have to choose your personal account. So from personal account, it will ask for like around it will ask for Apple account, Google account. So you can select your Google account. So I'll choose one of my account. So it automatically takes to this particular dashboard. So this is my dashboard actually. So using this Tinkercad, what you can able to do is like you can design 3D designs, or for 3D printing we can able to use this 3D designing component. Other one is circuits. Circuits is nothing but basic embedded systems. You can able to work with this particular Tinkercad. So what we need to choose is we need to choose this circuits. So this is our environment. On the top, we can able to see a few things, and all our components will be available on the right hand side. So on the top, this color indicates while connecting one object to the other object with a wire, we can able to change the color of this wires. So other thing is like copy paste and other applications while doing an experiment, we can able to do it. So to keep comfort to keep you comfortable with this environment, we'll do a simple project. So I'm just going to take a battery. I'm just going to click, drag it, and I'm just going to place it on the desktop. Okay, this is our work area. Okay, so what I'm going to do is I'm just going to rotate it. So on the top I can have like rotate R. So if I click this, it can able to rotate. So I've taken a battery. Now I'm going to connect a LED. So what I'm going to do is I'm just going to connect the cathode. So if I start the simulation, what exactly happened is this LED is burning. So what I'm going to do is I'm just going to put a resistor. I can change the value of the LED. I can change it to 230 ohm. Now start simulation. I can see that this LED is now glowing very much, very nicely. So this is the effort we are going to put. Like we can do it again. So for selecting a component, what you have to do is on the right hand side, you'll be having all these components. So you have to click on that particular component, you have to drag it and you have to place it in the workstation. So if you want to rotate this component, what you have to do is on the top will be having your rotate button. So if you click on that rotate button, it continuously rotate it. And what exactly we have to do is we need to fetch a LED. So what you are going to do is you can just click on that LED, drag it and place it on the workspace. So you can just remove this. So if there is a requirement like you need to change the color of the LED, so you can just click on this and you can change the colors. You can able to change the colors. If it is yellow, you can change it as yellow, blue. So likewise, you can able to do that. So as far as embedded system is concerned, we need a microcontroller. So here we have an Arduino microcontroller over here. So here I'm just bringing it. So what I'm going to do is, as far as microcontroller is concerned, this Arduino microcontroller is concerned, there is no need of resistor to be connected. So I'm just going to connect this to pin number ground, and I'm anode. I'm just going to connect it to pin number 13. So this is a simple connection. So what I'm going to do is, I'm just going to make this LED blink for a particular time, for a particular frequency of time. So for that, what we have to do is, I have to choose this code. So here I can able to see, you just remove this, you can bring this. This also you can remove it. The first thing is, the LED has to be blinked. If the LEDs need to be blinked, means it needs to keep turn on for a certain duration of time and turn off for a certain duration of time. So you don't want to write any code in this online application, embedded application. So what we need to do is, it is an output based thing. So what exactly we need to do is this, you have to choose this output, bring this to this coding area. So to which pin you have connected this LED? You have connected this LED to pin number 13. So you are connected to pin number 13. So your pin number 13 is now made to high. High in the sense, it is now made to glow. Okay, then it is assumed that it is going to be given 5-volt supply. Right? Then we need to give a small delay. So delay is in the sense, I'm just going to give a 1 second of delay. So the delay will be available in the control panel. Again, what I'm going to do is, again, I'm just going to bring this, not this one, set pin 13 to, now I'm making it going to low. So for a particular duration of a time, this LED will be turned on, and for a particular duration of a time, this LED will be turned off. So what I'm going to do is, I'm just going to put another delay here. So that's all. This is the effort which we are going to put for making this LED to glow. Okay. So now let us see what happens. So on the top, you will be having this button, Smart Start Simulation. So when we click on this, we can able to see it is now initiating, and we can able to see this LED is getting blinked for a particular frequency. It is turned on for 1 second and turned off for 1 second. So we can able to change the things also. Like if I need to turn on for 500 millisecond and turn off for 500 millisecond and start simulation, that LED blinking will be little bit faster. Okay. So here we are having a controller and there is a LED. This is a very simple application, like connecting your LED to a battery. So you can stop the simulation. So here on the top we can see this blocks. Okay. So if you convert this blocks to the text, so what you will be getting is, you will be getting the code for the Arduino. So this code can be utilized for the real-time implementation of your Arduino. Like if you are going to use a hardware, then you can able to copy this code and you can paste it in the Arduino software, and then you can download the code inside your Arduino and you can make it use in the real-time Arduino. So now let us go back to this block. So this is a very simple application. Likewise, we are having some sensors over here. Here we have some sensors. So let us see one by one. So this is another sensor. So this is a PIR sensor. PIR is passive infrared sensor. So if somebody is moving in front of this PIR sensor, it can able to detect that motion and it can give a signal to this controller. Corresponding to this signal which is being received to this controller, it can able to give a indication in a LED, or at the same time it can able to give a indication in the buzzer. So this is a buzzer connected to a controller, and the controller is being connected with a sensor. Sensor is nothing but passive infrared sensor. So this passive infrared sensor will be consisting of three terminals. One is signal terminal, other one is power terminal, and the other one is ground terminal. So this power terminal, we need to connect the 5 volt of your Arduino, and this ground terminal needs to be connected to the ground of your Arduino, and this signal terminal needs to be connected with any one of the digital pins of your Arduino. So these are the pins where you can able to connect the digital inputs and we can take digital outputs. And at the bottom we can able to see some analog inputs and analog outputs. So these are the GPIO pins, and here we can able to have, like, there is a 5 volt, two grounds are there, and one 3.3 volt is there. So not all the sensors will be working in 5 volts. Few of the sensors and few of the important actuators will be working in 3.3 volts. So for that purpose, they have given a 3.3 volt. So this is your Arduino. So most of the embedded system will be based on the if-else condition. If-else condition is nothing but if this happen, what we have to do. Like, we have many examples regarding that. Like, we have already seen that there is a boiler, so it continuously monitors the temperature of the boiler. If the temperature is going beyond that threshold limit, it automatically gives a sensor. That is, it gives an alarm. So it is a if-else condition. So if the temperature is beyond the threshold, it blows an alarm. So if somebody is moving before this sensor, it gives a alarm or it gives a indication, LED indication. So likewise, we can able to have develop multiple number of applications using the embedded system. All are based on this if-else condition only. So like if there is an automatic door is available, the sensor will be an ultrasonic sensor. So that ultrasonic sensor will be measuring the distance between the door and the person who is coming. So the distance is very less, automatically the door gets opened. So everything is comes under your if-else condition. So if the condition is true, a particular event will be happening. If it is false, it will be as it is. Okay. So for which we are also going to write a code that is very simple, similar to that. So here what we are going to do is we'll do it again. So there is a control here. So we have to take the if-else condition. Okay. So if-else condition needs to be taken. So in the if-else condition, there is a small diamond block here. So in that diamond block, we have to put this math. So math is nothing but we are just going to measure the if statement. Okay, I'm just going to fill it with this diamond box. So what you are going to analyze? So what you are going to analyze? You are going to analyze the input of your sensor input. That is pin number 2. That is read the digital pin. So which pin you are going to read? The digital pin is connected to pin number 2. So if it is equal to, that is, if the digital pin is equal to high in the sense, if somebody is moving before this PIR sensor, it means that is, it is going to read, your controller is going to read the digital pin 2. So if it is equal to high means somebody is moving here. If it is low means nobody is moving there. Okay. So if it is going to be moved, so what exactly it needs to do? So there is a LED connected to pin number 8 and there is a buzzer connected to pin number 7. So what I'm going to do is I'm just going to take this output and I'm just going to bring this set pin 0 to high. So set pin 0 to high, we need to change this 0 because LED is connected to pin number 8. So I'm just going to make it 8. So whenever my sensor is reading this pin number 2, that is pin number 2 is reading the sensor. If it is high, what happens? Automatically this LED will be turned on. Okay. So similarly, I'm just going to turn on the buzzer also. So I'm just going to bring this play speaker on. So there is another output called play speaker on, which is connected to which number pin? It is connected to pin number 7. So I'm just going to give it to 7. So how long it is going to play? That it is going to play for 0.25 seconds. So we have like different tones, like from 60 to 100, we can give any number of tones. In the else part, what you have to do is again output set pin number 8 to low. So this is it. So this is the entire operation. So there is a if else condition. So it is continuously reading the pin number 2. Why it is reading the pin number 2? It is pin your PIR sensor is connected to pin number 2. So if it is equal to high, so if somebody is moving, what happens? Your set pin 8, that is your pin number 8, which is connected to a LED, will start glowing, and at the same time, the speaker which is connected to pin number 7 will give a tone 60 for 0.25 seconds. On the else part, if nobody is moving before this PAR sensor, it will be always kept low. So we don't want to put the speaker on. Again, we don't want to put it off. So we can just remove it in the else part. Okay. So now let us start simulating it. So on start simulation, so you can just imagine this is the area. So this is the area. I think this is visible, right? So consider this is as a person. Okay, he's moving. So once that movement is captured, automatically this LED which is connected on pin number 8 starts glowing, and the buzzer which is connected to pin number 7 starts blowing, or your buzzer starts blow. So this is also another application. So similarly, like as I told here, you're having these blocks. So you can convert this blocks to your text over here. So you can just copy this code and you can have it in your notepad, so that when we are using it in the real-time Arduino, we can just copy this. What you have to do is you have to connect a PIR sensor to pin number 3, or pin number 2, a buzzer to pin number 7, and LED to pin number 8. This is the effort we are going to put for creating this motion detection system. So this can be otherwise called as burglar alarm. We call it as burglar alarm. So if there is some high security places, what we can do is you can incorporate this kind of burglar alarms. If somebody crosses, it automatically gives a alarm. Or it can be kept in the outside of our house. If some person approaches near your house, automatically that bell will ring, right? So this is your second project. So likewise, we have a lot of applications using this Tinkercad. So this is another thing. We have TMP. TMP is nothing but your temperature sensor. Temperature sensor, this is an analog sensor. So we have connected this sensor to A0. Okay, A0 is nothing but this analog input output pins. So I'm just connecting this sensor to your pin number A0. So similarly, you are having other two terminals. One is your power terminal and the other one is your ground terminal. So power terminal to pin number 5 volt and ground terminal to pin number ground. Okay, and we are going to connect two LEDs over here. So one is to connect it with pin number 7 and the other LED is connected with pin number 8. So the coding part is what exactly we are going to do is I'm just going to raise the temperature. I'm going to set a threshold value. If the temperature is going beyond the threshold value, red color LED needs to be glown. If it is coming below the threshold value, green color LED needs to be glown. So this is also very simple to that of the previous one. The only thing is we have changed the sensor. Rest of the things will be very similar. We are just going to use a if else condition over here. If the temperature is going beyond your threshold limit, that is the if condition. So your red color LED has to be glowed and your green color LED has to be turned off. So if it is coming below the threshold level, your green LED has to glow and red LED has to turn off. So this is a very simple code. So again, you can just look at it. I'm having a if else statement, if else condition. I'm just reading the analog pin A0. Previously, we were reading the digital pin. Now we are reading the analog pin. Okay. So when it is greater than or equal to 100, 100 is nothing but the threshold limit at which I am given. Right? So, if the condition is true, what we are going to do is I'm just going to set the pin number 8. 8 is nothing but the red color LED is going to be given high and the green color LED is going to be given low. Okay. Else part, what we are going to do is your red color LED is going to be kept low and your green color LED is going to be glown. That is, it has been turned on. So let us start the simulation and we can able to see that we can able to get a small rocking button here. So if the temperature is high here, hence your red color LED is glowing. So now I'm bringing it down. So automatically that red LED is turning off and green LED is turning on. So this we can able to see what is the current temperature using the serial monitor. So the serial monitor tells that now it is 33 degree. So if I'm increasing the temperature, we can able to see what is the current temperature right now. This is 82. Now I'm just keeping on increasing beyond 100. So automatically your green color LED turns off, representing that it has crossed the threshold value. So your red LED is now glowing. So for which what you have to do is after this if else condition, the output print the serial monitor. You need to print this thing. So what you are going to print is whatever which is being read in your analog pin, that is which is connected to your A0. The same thing it needs to be printed in the serial monitor. So print to serial monitor in this hello world. What you are going to do is you are just going to read the analog pin. You are just going to read the analog pin which is connected to A0. Right. So this is another example. So similarly, you can just convert it to your text and you can have it in your notepad so that if you are going to use it in the real time. So what are the things which is required is this is LM35. LM35 will be having 3 terminals. The first terminal will be a power terminal and the last terminal will be your ground terminal. And the center one will be your Vout. Vout is nothing but your analog voltage. Okay, and that is your analog input. And other one which is required is this your LED, a red LED and a green LED. Let us try to see one more project. So this is it actually. So here we are going to use a sensor which we call it as SR04. So SR04 is nothing but your ultrasonic sensor. So ultrasonic sensor is nothing but which is a sensor which is used for measuring the distance. Okay. So the distance between the sensor and the object will be measured, and based on that we can do some applications. Okay. So here this ultrasonic sensor, what it can able to do is like it can measure the distance of a person coming towards the door. So if the distance is very low, or there will be a threshold value. If that is less than the threshold value, what exactly happens is automatically door opens. Okay. So here what I'm just going to do is like I've connected this SR4, that is your ultrasonic sensor. It has four terminals. One is your power terminal and the other one is your ground terminal. And the other two terminal is trigger and echo. Okay. One is your trigger and the other one is your echo. So it has two different knobs in your ultrasonic sensor. Your your ultrasonic wave will be transmitted from the one knob, and it will be hitting an object, and it will be reflected back, and it will be received in the receiver. So the time taken for transmitting and it is receiving to this knob is being calculated, and converting from time to distance will be getting the actual distance between the object and the sensor. So when the distance is very low, automatically the door will get open. For showing the door getting open, I'm going to use a small servo motor. So the servo motor will also having three different terminals. One is your ground terminal, other one is your power terminal, and the third one is your signal terminal. So signal terminal, I'm just going to connect it to any one of the digital I/O. So power terminal, I'm just going to connect it with 5 volt, and the ground terminal, I'm just going to connect it with the ground. And similarly, here we are having a trigger and echo. So trigger is nothing but when the ultrasonic wave is transmitted, echo how it is getting captured. So for that, the trigger is connected to pin number 2 and the echo is connected to pin number 7. Okay. So similarly, we'll try to write the code for it. So this also comes under this if else condition only. So similarly, what we are going to do is read the ultrasonic distance sensor, trigger on pin number 2. So trigger is on connected to the pin number 2 and echo is connected to pin number 7. That is the only thing which you need to give. And at the same time, what you have to do is what you have to give is what is the distance, what is the threshold distance. So threshold distance is 100. So everything is measured in centimeters. Okay. So if it continuously monitors, this F conditions will be continuously monitoring the distance. So if the distance is going beyond, it automatically turns on your door. That is opens your door. Else the door will be kept closed. Okay. So here let us see how it is getting simulated. So let us start the simulation. So now it is coming to its initial position. So if I'm clicking this, this shows the distance between your sensor and the object. So this is an object and this is a sensor. So I'm just going away from the sensor. Now it is like 91 centimeter. Now the door is kept open. So I'm just moving away from the door. So you can see that door is getting closed. Okay, so it is just an indication like we are going to use a small servo motor. So it is just an indication like it is door is getting closed. Okay, not exactly the door. So if I'm coming towards that sensor, like below 100 centimeter, so automatically the door is opening. So if I'm going away, the door is getting closed. Okay. So similarly, what we can do is we can able to monitor everything using this Tinkercad. We can stop the simulation. You can select the blocks, block plus text. You can just copy this code which has been generated for you. Keep it in the notepad. Whenever you use a real-time Arduino, you can just copy it and paste it and use it in your real-time applications. Right. So this is one application, and we have another application. We call it as WorkWe. So this is the website for WorkWe. Here you can also try those things, all those things. So here you'll be having some um, basic examples by default in your website. So here there will be some varieties of controller boards available. So in this Tinkercad, you will be having only Arduino. In Woku, you'll be having like Arduino Uno, Arduino Mega, Nano, and at the same time will be having some IoT related things also. So this is that environment, like will be very similar to that of your Tinkercad. The only thing is like there will be an Arduino. On the top, you'll be having this plus button. You can click this plus button and you can just drag it and you have to place it. Okay, if you need an LED, you can just bring it like here. So you can change the color of the LED. Rest of the things are very similar to that of your Tinkercad. The only thing is you generate some code using this Tinkercad. Okay. So here it is connected to pin number 13, right? So what I can do is I can just copy the code. I can just copy this code and I can just paste it here. Okay. I'm connecting it to ground. This I'm connecting it to pin number 13. Now if I play, so we can able to see the same outputs. Okay, whatever we saw in the Tinkercad, the same thing is will be gotten this Workway website also. Okay, so whenever you have time, you can spend your time in this Tinkercad, and Tinkercad is also an amazing tool for 3D designing. If you have 3D printers in your college, you can make use of this Tinkercad for designing 3D things. So with this, we'll try to conclude our session. So thank you very much. If you have any queries, you can just post your queries.
Thank you, sir. Thank you, sir.
Yeah, thank you, sir.
Thank you, sir.
Uh,
Participants, if you have any query, sir, please keep the chat box on so that if
Yeah, just keep open. Sir.
yeah, yes. If any question, please write it in the chat box.
they are appreciating you, sir.
Yeah, thank you. Thank you.
If participants have any question, they may raise their hand so we can unmute them to ask any question.
Yes. How can we
Yes,
add sensor?
how can we add sensor which
Those
is
things are
not
default
available
things,
in?
sir. those things are actually default things. Sensor is nothing but like it happens like in a if else condition only. So most of the sensors will be like will be operating in the same situations only. So whatever sensor which we use is not a problem. So the code is actually the important thing. As this Tinkercad is an open source platform, online platform, whatever the sensors which is available in that platform, we can able to use it. But frequently they will be updating everything. Workway is also an open source platform. We can use Workway.
Participants, please. Any question? Any question?
You, sir.
Okay. Sir, please unshare your screen, sir.
Yeah, yes, yes.
Sir, one group photo. So please, participant, please turn on your camera so we can take one group photo. Okay.
Thank you. Thank you very much, sir.
Thank you, sir. Thank you,
It was
sir.
a very informative session, sir. Thank you.
And nice simulation, you means demonstration, simulation demonstration. Thank you, sir, for accepting our invitation. And we will meet again with this type of ATAL FDPs. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank
Okay.
you.
Thanks.